Hey guys, I really appreciate those of you that took the time to answer the discussion post. Um, some of you were off a little, some of you were off a lot, but the whole point is that um, if you were wrong, just learning what you did wrong because I know it has been a while since we have done the confidence intervals. So most of you chose to do the hypothesis test, which is fine. But I'm just going to tie in how they're related. And honestly, you don't really need to know this for the final. You don't like this is just something that I think is cool. So if you want to probably stop watching this video right now, that's fine. But I am going to explain how to find the answer for each one right now too. So the claim was that 1 out of 6 use a dating app to cheat. And, they thought that was too high of a fraction. So the random sample found that 43 out of 300 were using it to cheat. So, first of all, if we go back to just, oh no, the Hulk is coming. So, if we go back to box models for a second and just think if 1 in 6, so this is, okay, close the door because I'm doing a video, okay? So 1 in 6 are using the app to cheat, and that is the claim. Like that is what the population is. So they're saying, okay, 1 out of every 6. So one person is being that cheater, the other 5 are not, right? So this would be the box model. And then we're going to take a random sample of 300, right? And from that, we found 43 out of 300. Now, hold on. Let me close my door so you guys don't hear Hudson. Okay, sorry about that. So a lot of you just took this number, 43, and thought that was the percent. You guys got to use your brains, okay? If you did that, I'll forgive you this one time. But from now on, you got to use your brain. And I know it's hard because you probably haven't used your brain truly in a long time since 1st of March, right? I understand. But if you think whenever we have a fraction, we're going to be using EV percent because we're going to make the fraction a percent. We're not going to be doing average because there's nowhere in the problem does it say average. You have a proportion, so it's going to be a percent. So this is the EV percent, that 1 in 6, right? So that's EV percent, which ends up being 16.6%. So just round it to 17 if you'd like. And then this is from the sample. So that is our statistic, which ends up being like 14.3%, I think. Anyway, so let me just explain each one. I don't want to be forever long in this video. So remember, 95% confidence interval is simply the EV plus and minus 2 times the SE. So whatever it is we're looking at here, since we're looking at percent, then it's going to be EV percent plus and minus 2 times SE percent. Okay, EV percent's the 17, which is the 1 out of 6. SE percent I found by doing the SD, right, which is square root of 0.17. And remember, the SD comes from the box, the population, not from the sample. Unless we don't know the population, then we use the sample, okay, because that's all we have. But this one, we always use the box model for the SD. So then it'd be 0.17 times 0.83, which is, I think, like 0.37 something. So then we divide by square root of 300 times 100. Anyway, I didn't really want to show that because in my mind, you should know how to do that. But that's SE percent. And then if you actually simplify that, it should be 12.66% to 21.34% is the 95% confidence level of those that use that dating app to cheat. Okay. And moving on to the hypothesis test, which would be a one sample z-test. One sample, because we only have one sample, we're not comparing it to anything else. And well, we're really comparing it to the claim, which is just the null. But anyway, we only have one sample. So it's one sample and it's a z-test because that sample size, folks, is greater than 30. So that's why it's a z-test, not a t-test. So the null would just be that 17% use it to cheat, which is what the claim was, right? From the one out of 6. And the question was, is that too high? So the alternative would be less than 17% use it to cheat. Okay. So then remember the z-scores observed minus expected divided by SE. So again, since we're dealing with percentages, observed percent minus expected percent divided by SE percent. Now at z-score, I got like negative 1.24. Then you plug that in to find the p-value. So the probability of observing this or more extreme. And that is 10.7% of the time. So that means we are going to fail to reject the null and have evidence that 17% use it to cheat because we have evidence supporting the null. Okay. Now, what I wanted to show you, and I should have had you do a 90% confidence interval instead of 95, but that's my fault. I just wasn't thinking at the time. So, see, it happens to all of us, you know? So 90% confidence interval, the only thing I would change is what I multiply the standard error by, right? So instead of the z-score being 2, the z-score is about 1.64. So then I would go 17% plus or minus that, and it would make my interval smaller, right? So instead of 12.66 to 21.34, it's a little bit smaller. It's going down to 13.44 to 20.56. Okay. So this is the tie between them. And I think this is what I think is cool. And maybe it will help some of you. Maybe you don't care. I don't know. But our observed percentage, did it fall into this interval? So we observed a percentage. This was 14.3, right? So we observed 14.3. Is that in our 90% confidence interval? Yes, it is. So therefore, we are not going to reject the null because it's likely to happen. It's in our confidence interval. So if it was outside the interval, so anyway, sorry, I made a note here. So any observed percent in the 90% confidence interval is likely to happen. So we would not reject the null. We would fail to reject the null. Okay. Any observed percent outside of the 90% confidence interval is unlikely to happen. So if we observed if the random sample had 12% of people or 10% of people or something like that, then that's outside the 90% confidence interval. So that's unlikely to happen. So therefore we have evidence against the null, which is what I wrote right here. Okay. So kind of how it ties into, I drew a normal curve for each one so you could see. But so if we have a 90% confidence interval, that means in each area area of the tails, we have that 5%, right? Okay, close the door, please. Anyway, so we have that 5% if we're 90%. So this ties to a one tail test because in one tail, there's that 5%. So if we're comparing our p-value to 5%, which is also referred to as the significance level of the test, which is what we have been mostly using for this class. But anyway, so it is compared to a one tail test. So if it's outside that, you would reject it. If it's inside that, then it's likely to happen and you would not reject the null. And then I tied that to a two tail test. So if our alternative hypothesis was not less than 17, it was just it's not equal to 17, then it would be a two-tailed test, which means then we would want to compare it to our original 95% confidence interval. And if it's in that interval, we would not reject. If it's outside, we would reject. So I know this is crazy, weird. I don't know if it'll make any sense for you. I tried to explain my best while my kids are like wanting to kill each other out there. So, thank you for listening. If you want more explanation on this, let me know and I'd be happy to explain it or even post these notes if you would like that. So, anyway, have a great day and we'll talk to you next week.